Okay. Rest. Okay, I think we're ready. Welcome everyone to the 6th edition of Elixir Community Kraków Meetup. Before we get started, that may be the last chance to grab a beer or a juice from the kitchen behind my back. If you ever going to need to go to the restroom, you can use the ones near the elevators over there. And the pizza, as usual, going to be after the presentations. We have 4 presentations today, 2 on site, 2 remote. But before we go to the presentations, there's a bit of an announcement to make. As you may know, we're organizing RTC On conference covering topics of streaming, multimedia, WebRTC, and computer vision. I hope you're interested in those topics. If you are, we're launching very early bird tickets right now with the half of the price that's going to be. This is very early tickets. These are very early tickets, so we don't have a lineup for the presentations yet, but you can see the lineup for the workshops. The workshops are intended for also for beginners, so if you're new to the topics covered by the conference, you can check them out and learn something on multimedia or WebRTC. Especially if you're interested after the last presentation today. And here's a little bit of a surprise. This QR code, if you use it, will get you to our newsletter. This newsletter is special because it will grant you another 15% of discount to all the tickets. And additionally, there's going to be a lottery. So for all of you who will sign on the newsletter, they'll get the chance to receive 1 ticket for free. The ticket will cover the 2 days of talks, the merch, catering, and after party. So if you would like to have a chance to get that ticket, sign on. This newsletter is not only for the discount. You will get dev tips and tricks from the membrane team on streaming, multimedia, and so on. If you ever seen Membrane Mondays on Twitter, that's something like that. You may expect there. And yeah, the news on the conference itself. So if you're interested, please scan the QR code and join us. All right, that's it from the announcement. We're going to start with the remote presentation from Moriarity. He's the author of Generic Algorithms in Elixir, co-creator of NX and Axon libraries. So I guess it is well known to all of you. And he's going to present on large language models. Oh, yeah. Hi, Sean.
How's it going? Yeah. Hey, everyone. Thanks for having me. You want me to go ahead and share my screen and just get started? Cool. Can you all hear me?
Yeah.
Okay, great.
We can also see the next presenter. I don't know if that's intended.
Should I leave this call until it's my turn to start? How do we want to do that?
I'm okay if you stay. I don't know this.
Here, I'll turn my camera off so it's not distracting.
Okay, we can see here the presentations. Okay, so Sean, you can start if you're ready.
Awesome. Yeah. So hey everyone, Sean Moriarty. As said, I'm the co-creator of NX, author of a couple of Elixir books, and just generally do a lot of machine learning stuff in Elixir. So this talk is somewhat machine learning related. It's really focused on large language models. Not going to really talk about NX, but you can hopefully see how this is going to tie into NX. This talk is about my new favorite library in the Elixir ecosystem called Instructor. That's inspired by a library in the Python ecosystem that's pretty popular, also called Instructor. And the subtitle is How to Use LLMs Correctly in Production. And that's a pretty strong assertion, but I think as you see this talk, I think it should, hopefully, if you're not familiar with it, change the way you think about using large language models in a production setting. So I'm going to guess that a lot of you are probably using large language models right now in one form of another. I don't know if by a show of hands how many people are using large language models in their like production app, not just using like ChatGPT. I can actually see the audience, so I'm just curious to see what the results are here. Maybe, I don't know. It's actually kind of hard to see on the screen, but I'm going to assume that a lot of people are using large language models in one form or another to augment some workflow. But I would assert that a lot of people are not using large language models correctly. Or if they are trying to use large language models, you might find that it's very difficult to control some of these open-ended generations and to integrate them into what you would call, maybe it's harsh to say a legacy software workflow, but certainly a like deterministic software workflow. So I did a talk at MPEX in 2023. It's on YouTube if you want to go watch it, but it's essentially a rant about how the large language model revolution is something strange, because I think like as ChatGPT and these other like production large language models have come out, everyone has like looked at them and said, yeah, these are really awesome, they're really powerful, but I haven't really found like a killer use case for large language models outside of people that are building chat apps. And so what I mean by that is that like people that are building products that are powered by large language models usually try to market the large language model as the application and not necessarily as a fundamental part of their application. So essentially the theme of the talk is that you shouldn't just build an app that's enabled by a large language model for the sake of it, because large language models are powerful tools that are meant to augment your application, but they're not necessarily meant to be the actual sole workflow in your application. And this kind of goes along the lines of, so when you first saw an LLM, you probably thought of a million ways that could be used in your application. I think I was kind of the same way. I thought you see what these large language models can do, and you think to yourself, this is incredibly useful. This is something that I could totally use. But then when you actually got around to it, integrating it into your application, you realize that it's very hard to integrate a non-deterministic, open-ended string completer. And that's a harsh word. I know that large language models are not necessarily string completers, but integrating something that does what a large language model does into your old school software application is hard. And the truth is that's because the primary purpose of all software applications is to turn data into useful outcomes. And traditionally, we model data in some, I would say, language-specific way. So in Elixir, we have Ecto, and so we model our domain using Ecto, or as we're going to see later on with Ash. So there's a lot of ways to model your domain, your problem, but these necessarily don't tie directly with what a large language model does. So it's very rare for your domain to like perfectly match what a large language model does and provides to you. That's chat completions and open-ended completions. And so for that reason, it's very difficult to integrate these things directly into your applications. So yeah, once upon a time, and this is my talk in MPEX, I said that we should start thinking of large language models in the same way that we think about databases. And I didn't necessarily mean that in the way that like you should go and query a large language model like you would query a database and expect like a deterministic output. But it is a useful segue for the concept I'm going to present to you here. So if you think about how you use a database in your application, you have your database on the left, and that maps directly to some schema or ecto schema in your application. So here I have a Postgres database, for example, and I have a contact schema, and that contact schema has a first name, last name, email, and phone number. So this is kind of useful because this is essentially exactly what Instructor gives us, where I can take the outputs of a large language model and map that directly to an ecto schema. In this sense, I can treat the outputs of my large language model as I would say, a first-class citizen of my application. So this is essentially what Instructor is. Instructor is, it's a way to do what we call structured prompting. So structured prompting is, if you're familiar with the OpenAI function calling, that is essentially a way to get structured or JSON outputs from large language models in a reliable way. So if you have worked with large language models pre-function calling, you might have had some interesting workflows where you're, prompting a large language model to please give you JSON outputs, or, please separate each whatever output by a new line so I can then have some weird string parsing and hope that the large language model gives me a correct output, and doesn't have any trailing new lines or trailing characters or anything that sort of mess up this deterministic workflow. The original instructor library is actually a Python library that maps large language model outputs to Pydantic models. So if you're familiar with the Python ecosystem, Pydantic is similar to Ecto. It's just a modeling library where I can represent data structures with, like, I would say, safe typing and all these good things. And it essentially, what an instructor does in the Python ecosystem is it maps large language model outputs to Pydantic models. This instructor EX library is written by Thomas Millar. I've got his Twitter linked right there. And it's an exact clone of what instructor is for the Python ecosystem, but written in Elixir. If you're a JavaScript fan, there's also an instructor library for Zod, I think it is the modeling library in JavaScript. So just an interesting tidbit, but instructor is something that you can replicate across a number of different languages because it's a relatively simple concept. So as I stated before, what it does is it coaxes your large language model outputs into Ecto schemas, so you can treat them as a native part of your application. So I have my Ecto schema for a contact here, and then I create a validation change set. So here I am taking a contact, or that should be a change set. I validate the fields that I want to be required. I validate my email, and then I call a chat completion here. So this is an example. So, let's say, for example, you have an intake form where someone can just leave some sort of request for help with their contact information. And you can see how this would very easily be replaced with traditional form. But if for whatever reason you're getting an open-ended output like this from something somewhere, and I've got some examples in my demonstration here in a second, and then I can pass this open-ended content to this chat completion, and I have this response model there, which is my contact, and this will actually get the output will get coaxed into that Ecto model. So then I can use that contact directly in my application. So now on to the more interesting part of the talk. We will go into the demonstrations. Can you all see my live book here? Is the font okay? Yes, no? I can make it a little bit bigger. Ooh. Well, I guess I'll continue through.
Okay, can you make it a bit bigger?
A bit bigger? Okay. Is that good?
Is that okay? Okay, we can continue. Thanks.
Okay, cool. Yeah, so this is that Ecto schema that I had there in my example. So you can see I have this contact, and I'm using an embedded schema here because it's not mapping to any sort of like table or external data store, but it very easily could if you really wanted it to. I define a validation change set. And so this is something that you probably already have in your application. You have a ton of schemas that represent your domain or your problem domain. And so I define this module, and then I have my example content here. So I have this saying, hi, my name is Sean Moriarty, and I'm looking for help. My email is this email, and my phone number is this. And so this is just a traditional data extraction task. So I'm taking some open-ended input, and I'm trying to extract a structured output from it. And this is something, if you were using LLMs like pre-function calling and pre-instructor, you probably have some like crazy prompt that is begging your large language model to please return you valid JSON, to please return you like XML or something that you can reliably parse, and you're just hoping that it gives you something correct. With instructor, I can simply take this and it will actually call it. And I know I'm using OpenAI here, but this is something that it's an adapter-based library, so I could very easily replace this with an open source large language model like Llama 3 or whatever else is out there. And you can see that running this is going to use, it's going to call out to GPT 3.5, and then it's actually going to parse the returned value into this context schema. One thing you notice is it actually has an ID. That's because this Ecto schema has an ID by default, so I can just enable or disable this primary key, and then it should not return an ID with my result there. And you can see it actually correctly extracted the data that I wanted from this open-ended output. If you actually get bad data, because you're just working with change sets here, so I have this validate change set. If for some reason, and this is probably a pretty bad example, but if you don't want your large language model to like extract bad information for whatever reason, you can just enforce those validations as you would as if it was any other regular part of your application. So here I have the same exact prompt, but I'm saying my email is bad_email, which is obviously not a valid email. And I give this to instructor, and rather than getting some sort of like JSON or something that I then have to validate, I actually get a change set back that I can handle directly in my application. So this is something that's very convenient, because if you worked in Elixir, you've obviously worked with Ecto, you've worked with change sets, and so it's something that should be very familiar and is very easy to integrate directly into your application. Now, there are some other things you can do with instructor that I think are pretty interesting. So I call these like smart validations. So if you've done things like worked with like spam filters, or a good example would be like validating like profanity, or whether or not speech is hate speech or something in a machine learning setting. You know how difficult that can be, and it's also something that like usually requires a bunch of glue code to pass your regular data through some like machine learning service. With instructor, it's actually relatively simple to do LLM-based validation. So it provides this convenient validate with LLM that just works natively on the change set. So in this example, I have a tweet here with a username and a string, and my validation is just a prompt here. So I'm telling instructor that I do not want it to allow any tweets to get through this filter that are about crypto bots. If you've been on Twitter, I'm sure you've seen all of the crypto bot tweets that are out there. So I say, hey, look at this content field, and make sure that you return an error on this change set if there are tweets here about crypto bots. And so this is just a regular Ecto schema. If I have some software that like extracts tweets for whatever reason, then I can just use this without having to do anything crazy with my application. Now I have this tweet, and I do a cast all here, which is going to cast this map here into to that schema, and then I'm going to validate that this is either a crypto bot tweet or not. And so this is like an actual spam tweet that I had pulled directly from Twitter, and I do this cast all, and it's going to actually call out to GPT 3.5, and it returns these errors. And this says, hey, the content is invalid because it contains hashtags related to cryptocurrency, blah 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 blah. And so this is something that you could actually like return to your users. Hey, like this is spam. This is an incorrect, or this is spam. This is profanity. This is hate speech. This is whatever. So you can do these non-deterministic or these very involved validations without having to come up with some like crazy logic or building out like an external or separate machine learning service. And this will actually I think it should not return an error here. In some cases it does. Yeah. So it's not perfect. And this is something, there was a quote I saw like very recently about working with large language models that like, I think it was, they're very powerful, but like sometimes you build in a non-deterministic part of your application that's impossible to debug. And so there are downsides to using them. And so this is maybe a good example of that, and that it is saying that this is an invalid tweet. And it could be that just because we're using GPT 3.5, but just a good example of some validations that you can do. One of the things I really like about instructor and large language models in particular is that if you have a like machine learning based application that relies on several different machine learning models, you can usually simplify your machine learning deployment by using just say like a single large language model, and then taking advantage of all of these different, I would say like structured outputs to model these problems. So a good simple example here is, say you have an application that parses news articles and extracts like named entities, it extracts the sentiment, it extracts the topic. It does a number of these like NLP-based enrichments on this article. And so this is something that before LLMs, you would have to do with multiple different models. You would train a model that is a like named entity recognition model specifically for this problem. You might train a sentiment analysis model specifically for that problem, and you might train a topic model. With instructor and large language models, I can come in and just define a schema for each of these problem domains. So here for named entity recognition, I have an entity, which is a string, and then a class. So an entity is either a person, organization, location, or other. Sentiment analysis is just a classification problem. So I just define a schema with a class that can be positive, negative, or neutral. And then topic modeling. So I can say that this article topic is about energy, finance, politics, sports, or other. And so I can define all of these, and then I have, I would say, is the world's simplest machine learning service here. It's just a series of chat completions. So I have NER here, and rather than having a separate NER model, I'm just using, and that should be Turbo, I'm just using instructor. And then I have sentiment analysis, and same thing. It's just an instructor call with a different response model. And then I can run all of these, and I've got a long article I pulled here. So I'm a big baseball fan, Philadelphia Phillies. So I pulled a Phillies article here if anybody watches the Major League Baseball in the United States. And I can do sentiment analysis, and this will return, hey, positive, and this topic is about sports. And so this is an example of doing all of these things separately. Another cool thing you can do with instructor is you can actually have nested schemas. So if I have a set of enrichments I want to apply to an article, then I can just define a schema that has all of those separate enrichments I want to apply. So in this case, I have my article, and I want to embed many entities. So I want to extract all of the named entities from the article. I have a topic, which is just like the topic that I described above, and then a sentiment. And then I'm going to include additional field here, and I'm going to say I also want a summary of the article as well. And so I'm going to define this schema, and then I run this chat completion. I'm just going to say enrich the following article, and let this run. And this could take a little bit because it is a little bit more of an involved task. I'll wait for this to complete. And I get these outputs here. And you can see it actually extracted all of the entities, and you got to remember to do that primary key false. I did not do that there, but it will fill that in. But it gives me all of these entities that it pulled out from that article here. It tells me the topic is sports, it tells me the sentiment, and it actually gives me a nice summary. And so this is I think it's really cool because I didn't actually do much prompt engineering work here. I didn't have to do much of anything to tell GPT 3.5 that this is what I wanted. I just defined my schemas, and it gave me what I wanted back. So you can actually, and there's an example of this, you can describe each of the fields you want. So if your problem is a bit more involved, you can actually provide a documentation for your schema and describe each of the fields. So this is an example of using instructor in sort of like an agentic workflow. If you're building something that relies on agents or decision making, then I think instructors is a pretty good example or pretty good library for doing that. So this is actually a schema that I used for a home automation project that I did. So I have a smart home it's got smart locks and cameras and alarms and everything. And so I defined a schema for an agent that would decide based on a command that I gave it whether or not to say lock or unlock a door, to set the alarm to a certain status, to view one of the cameras, or to just do nothing depending on what I said. And so here I'm actually describing the action I want it to take. So for a problem where it's not necessarily, I would say, described well with what your schema is, you can expand upon what each of the fields is. So in this case, I have my actions, and I describe what the actions are and the behavior that I want based on the prompt that I'm going to give it. I have my states and my camera. And so I have the schema, I'm going to define it. And then I have this chat completion with a system prompt that says turn the user command into a home action. So in this case, I'm saying, hey, can you lock my front door? And I run this, and my result is set lock to the lock state of lock. And I can say, turn on my alarm. And then I get a set alarm and alarm state home. So this is something where you can see how I can very easily turn this into something that is, uses an API or makes a call out to some home security API or whatever. So I would say with very minimal prompting, I get a data structure back that is native to my application and makes things really, really easy to work with. Final note that is pretty awesome is the instructor also supports vision models. So we have these large language vision models like GPT-4 Vision. If you have access to GPT-4 Vision or Lava, for example, if you're using the Llama CPP, then I can do the same exact thing I would do as if I was working with text, and I just define a schema. So in this case, I have a receipt, and then let's say I want to take a picture of a receipt, and I want to get the expenses on that receipt, and as well as the total from the receipt. Now I'll pull up a picture of what the receipt looks like here in a second. So I can define this schema, and then I have this PNG that I'm going to read here, and I to turn that into a base64 image, and I'm going to use GPT-4 to actually extract the expenses on this receipt. And so this will take a second. And now you see that it has actually pulled out the expenses. It has front and rear brake cables, quantity of 1, the prices, and then the total as well. And so if I pull up a picture of this, hopefully I can share this picture. Let me see. I should have prepared for this. Let me paste it into this slideshow. So this is the actual receipt, and I will full screen this. And so you can see 154.06 was the actual price I got. That's the total. And front and rear brake cables, new set of pedal arms. And so this actually matches the output that I got from Instructor there. So hopefully that very brief introduction to Instructor gives you sort of like an idea of the powerful things you can do with structured prompting. I think if you're working with large language models in like a production setting, that you should be using something like Instructor, unless you're building, let's say, like a chat application or something that involves like open-ended chat, then I think it's okay to just work with the large language models as they are. But for many of us, chat's not the domain that we're working in. And so it requires this sort of glue that allows us to marry the power of large language models with our traditional software application. Now, I know I did work with OpenAI in this, which might be a faux pas for me as the one of the maintainers of NX and Axon and Bumblebee. This will come to Bumblebee at some point. I have to finish something that's called constrained sampling. So what constrained sampling is basically defining a grammar for your large language model's generation to follow. And then your model will always generate valid versions of that grammar. So you can pass grammars for JSON in this case, or you could pass grammars for actual languages. In some cases, using constrained sampling can actually be much faster and more memory efficient. There's actually some work from a library called VLLM that I think it's VLM, it might be someone else, but that shows that constrained sampling can be faster. And this is something that hopefully we get built into Bumblebee. Some of the other things working with large language models, quantization and model partitioning. So if you want to be able to run like Llama 70B on a consumer hardware or Llama 400B on consumer hardware, then these are some things that are required and hopefully are coming soon to NX and Bumblebee. That's it for my talk. Hopefully I was not too quick through, and we've got some time for a decent amount of questions. So.
Thank you very much. Okay, and it is actually time for question. I hope you can hear us. Is everything okay?
Yep, I can hear you guys.
Okay, so do you have any questions? Yeah, there is one.
Hi, you talk about putting this on production, and a big concern about and debates about large language models is the privacy. So many people want to have their own private, let's say, engine, not ChatGPT. So is it possible to use your framework to connect to a private cloud where there is a large language model that you maintain?
Yeah. So one thing I guess I didn't mention is that Instructor is an adapter-based library. So the default adapter is the like OpenAI adapter that hits the actual OpenAI API. But as long as the model or like the model API you're using supports the OpenAI's like V1 chat completions endpoint, which I think it's Llama CPP, all of these like native or local LLMs do. As long as your server supports that endpoint, then Instructor is able to work with it. So you can use Llama 3, Mistral, all of these open source and local LLMs with this very easily. And that's actually, I would say, another advantage of using this library is that in order to change the large language model you want to use, it's just a config change. So if you're switching providers or you're changing to a local model, then it's very easy to do.
Yeah, thanks. Are there any other questions? Oh, yeah, there is one.
Yeah, so as you said, it works with any model you want. So if it's just an abstraction over a typical string output, how does it exactly work underneath everything? Is it just begging for this JSON?
So how it works, so OpenAI's, this was originally built for OpenAI's function calling API, which depended on a JSON schema. And so I believe OpenAI is probably doing some sort of constrained sampling, but nobody actually knows. But what Instructor does is it compiles your ecto schema into a JSON schema. And then for the frameworks like Olama, they support GBNF grammars. So you can take that JSON schema, convert it into a GBNF grammar, and then it will ensure that the output you get from that model is valid using this constrained sampling approach. So it's a little bit more reliable than like prompting and saying, like begging the model, like please follow the schema, because obviously it doesn't always work. So yeah, it compiles the ecto schema to a JSON schema, and then the servers are actually the model servers are actually what implements the constrained sampling behavior.
Thanks. Any other questions here? Oh, there's one. Long walk.
Thanks, great talk and great library. Is there any way to get like some kind of certainty of how like it's likely that the answer provided is like valid and it's actually like kind of reliable for the production use?
Yeah, it's a good question. So I don't know if there's like a guaranteed way to say like, yeah, this answer is valid. Like really the only guarantee instructor gives you is that the schema you get back is valid. And it actually supports a setting as well where you can do like retries. So if for some reason you get a schema that's not valid, it'll retry it a few times for you intelligently. But so like this only does guarantee the validness of the schema, but not the validness of the response. And that's where you would have to bring in some more, I would say, like advanced workflows that use like either retrieval augmented generation to tie a response back to a source, or some other things like chain of thought or tree of thought to make sure you're actually getting like a correct answer.
Okay, thank you. Any other question? Okay, I don't see any. So yeah, thank you very much, Sean. Thanks for joining us.
Yep, thank you all, and hope you all have a lovely evening.
Yeah, thank you very much. Yeah. All right, and before we go to our second speaker, I would like to mention something that I forgot to mention about in the beginning. Especially to those watching online, if you're watching on YouTube, there's an experimental transmission of this event on using our Elixir WebRTC implementation. The links are available in the Meetup site and practically everywhere, and in the YouTube itself. So if you want to help testing guys from working on Elixir WebRTC, join the stream, and you should see the transmission with way lower latency. So if you're trying to run it here, you can, but please just do not do it all at once, because our Wi-Fi will be poor and you won't see anything. Okay, and we're ready with the second speaker. You can come in and start setting up. Who's going to present the usage of Elixir in asciinema? Marcin, whenever you're ready, you can start.
Okay. All right. Okay. Hi. Before we start, I just want to get one thing out of the way, which is how to pronounce the name of the thing I'll be talking about. It seems there's a problem with it, and Hacker News notoriously has like they're just trying to figure out, and there are all variations of pronunciation of this. Asciinema? No, not really. Asciinema? Yeah. Well, someone said I've always pronounced it asciinema. Not really. So yeah, I pronounce it asciinema because it's a combination of English ASCII and ancient Greek kinema, which means movement. Kind of smart name, and sometimes I wish I've chosen a different one, but here we go. 14 years later, it's too late. So about me, I'm a computer geek. I've been working with computers my whole life, and currently I work as an independent consultant. I specialize in Elixir and Rust development. I've been involved in open source for last 15 years, and I've created asciinema, which I'll be talking about today. So what is asciinema? It's a suite of tools for recording, replaying, and sharing terminal sessions. Soon it will be also for live streaming terminal sessions. The source code can be found on GitHub under asciinema organization. There's a documentation page with comprehensive information about all types of things you want to do with it. And you can follow the project on Mastodon. The project is built out of 4 components. There's the CLI, which is the thing that you run in your terminal, and that's the thing that actually records the terminal, either to a file or streams it somewhere. We'll see where in a moment. So the player is the second component of the project. It's a web player running in a browser, which looks like a typical video player, but it doesn't play video files. It plays light terminal session recordings in ASCII cast file format. Nice thing about the player is that you can actually pause the playback and select the text and copy and paste it. You can't do that with a regular video. Another component is the server. The server we'll be talking about today quite a lot. And the server provides a hosting platform for the recordings and also acts as a live streaming relay. And all of the 3 components, the first 3, they embed a library I built called AVT, asciinema Virtual Terminal, which implements sort of a terminal emulator, but a headless one without any GUI, which can be programmatically used to query the virtual state of the terminal window and do some other cool things with it. So how it all works? It all starts with the CLI, where when you run it, it uses a thing called PTY, pseudo terminal. This is a capability of Unix systems which allows a program to become kind of like a man in the middle between a shell and a terminal window, intercepting all the output that the program produces. So this is what asciinema terminal recorder uses. And this is the PTY is used in other things you use daily, like SSH, Tmux, and things like that. There's a more like in-depth information about how it works on the documentation side. So the CLI allows you to record, replay also inside the terminal, upload a recorded session to the server. There's one I maintain at asciinema.org, which is like the primary asciinema server instance, but you can self-host it as well. And you can also run asciinema stream to live stream in terminal. Initially, the recorder was a simple Python script, like 14 years ago. It was growing, and then I was liking working with. I work less with Python these days, so I just rewrote it in Rust. The player, as I mentioned, kind of looks like a video player, but it's built from scratch with JS. Embeds AVT library, so it embeds its own virtual terminal emulator to basically like get a view of what's happening in terminal and then render it using typical browser capabilities like span elements with different classes and styling. And the server. So the server is the thing that we'll be mostly focusing on from now on. The server also uses the AVT library to get some. We'll see in a moment. But yeah, also embeds the AVT library. Again, the library is written in Rust, so the Elixir application uses Rustler library to bridge those two, basically turning the Rust into an if that Elixir code invokes. The server, and basically the whole project was started 14 years ago. It's quite a lot of time. And it was, back then, a Ruby on Rails application. So it was fine, but then 7 years ago, I did this, and it became a Phoenix application, Elixir application, and it was a really good decision because it enabled a lot of cool things that we will see in a moment. So the server provides basic hosting features like a typical video hosting site would provide. So a page with a recording, some index pages for exploring what people uploaded. Also like a profile page where you can see my list of my recordings and that I currently live stream. That's a screenshot. I currently don't stream. Okay, let's talk about tools. So there's quite a bunch of libraries that asciinema server uses under the hood. Most of those are actually used in this live streaming feature that's almost there. Like it's ready, it's working, but kind of not fully announced yet. But those things we'll look into, and those things are in use by the live streaming feature. So the CLI can stream your terminal in two modes. One mode is the local server mode, which starts a built-in HTTP server with a basic page with an embedded player. You can open it and you can watch it. If you're on a local network, that works, and the stream doesn't go through any third-party server or outside of your network. There's a second mode, relay mode, where asciinema server is used to forward, to accept the stream from the command line, from the CLI, and to forward this to all the viewers that have the player connected to the stream in their browsers. and we'll look into that now. So all of the things that we saw, the list of tools there, most of them actually rely on a properly formed Erlang cluster, like Phoenix PubSub, Phoenix Tracker, Horde, etc., etc. So the server uses lib cluster to automatically connect all the server nodes together in a cluster, and then it all just works like magic. So here's a ASCII diagram of the streaming feature. So at the top we have the CLI, which runs in your terminal. It opens the WebSocket connection to a producer socket on the server. The producer socket forwards the incoming stream to the stream server. Stream server is a gen server we'll see in a moment, and it just is a kind of like a manager of the stream. The stream server forwards the stream to all the consumer sockets. Every viewer connects from a browser, from the bottom looking, opens the WebSocket connection as well to a different endpoint, and gets the stream forwarded from the stream server through consumer socket. So Livestream Producer, handles the WebSocket connection of the producer, so the CLI that streams. It receives the session stream, it parses it, forwards this to, as I mentioned, forwards to the stream server. Also performs things like authorization, bandwidth control, supports several encodings, and does a few other things. So first thing, it implements Cowboy WebSocket behavior. So Cowboy web server, which Phoenix uses by default, has this ability to implement your own WebSocket connection handler, which runs as a process, and you just need to implement a behavior and configure routing. So you can't easily do that in the Phoenix router, but you can configure the endpoint, specifically the dispatch configuration, to inject your own WebSocket handling modules. So there are two endpoints for the lowercase s, ws/s, and ws/uppercase s. Those are two socket handlers for the producer and for all the consumers, aka viewers, and it delegates everything else to the standard Phoenix endpoint. Implementation is quite simple. You just need to upgrade the HTTP connection because Cowboy treats that as a way for you to extract some information from the incoming HTTP request. So it passes the request here. You can, from the bindings, which are like parameters, extract the information, and then it will upgrade the connection to the WebSocket, and then it will start accepting the messages. So every message sent by the CLI will be handled here, and the producer socket will supports multiple, as I mentioned, encodings. So it can accept raw binary. It can accept asciinema live stream binary encoding, and also text, which would be just a JSON encoded events. And this producer socket also does this thing where, like, if it terminates and the reason is remote, which means that it was cleanly closed by the CLI, so that means that someone who was streaming just finished the session, just ended it. then we also stop the live stream server, the gen server we'll see in a moment, because it doesn't need to run anymore. Yes, so the next thing, dynamic supervisor. So every time a new producer connects, we need to spawn this new stream server. And I use dynamic supervisor here because upfront I don't want to run all the processes for all the inactive streams, right? So this uses dynamic supervisor, and mostly starting the servers through this ensure child function, which ensures that it runs. It tries to start it. If it gets an error that it's already running, fine. I just want to know it's there. Bandwidth control. Another thing that producer socket does is something that initially I thought, or I never thought of it, but the thing is that the terminal streams are very unlike regular video streams. They don't have a fixed bit rate. So video stream has like 1 megabit per second or something, and it's fixed one. Here, the amount of data that arrives from the producer highly depends on what's going on in the terminal, because it's all event-based. There's no capturing the terminal window at a fixed frame rate. There's everything is event-based. So if I just go for a coffee and during my stream, no messages are being sent. But if I run some high frame rate animation, there will be a lot of data being sent. So to prevent abuse and resource exhaustion on the server, I implemented a bandwidth control using a token bucket algorithm. It's a really cool algorithm and very simple, actually, used in Intel communications, which basically let's look at how it works. So for every producer who connects to the server, there's a bucket of tokens, and 10,000 tokens are added to the bucket every 100 milliseconds. So there's at the rate of 1 megabyte per second, and 1 token is 1 byte here. The bucket can hold at most 60 million tokens, so 60 megabytes. If a token arrives when the bucket is full, it is discarded, so there's like a maximum amount of tokens you can have. And when a packet arrives, so someone printed something in the terminal, and so there was like a text, hello world, that would be like 10, 11 characters, let's say. So we see if there's a budget for that. If there is, then we just continue, just take those 11 tokens from the bucket and forward the data to the stream server, which will forward that to all the viewers. But if there are fewer than n tokens, then we just close the connection because someone just bombarded us with lots of data. So that's one thing that also producer socket does. So now the live stream server, that's the one that started by dynamic supervisor, and this guy just manages the stream, does a bit of bookkeeping, maintains some statistics, and publishes all the stream events using Phoenix PubSub, so the consumer sockets can subscribe to it and forward it through the WebSocket to the browsers. Right. So since there can be just one, there should be just one stream server in the whole cluster, we need to make sure that there's only one running. Doesn't matter on which node, but we need to be able to locate it easily. So I used Horde registry library, which allows process registration through its own implementation, a distributed one, and using the name option here and using the via tuple function, which tells OTP to register the name of the process using Horde registry. And then all of the interaction then goes through also using the via tuple, because we need to first locate where is the process there, on which node, and how to call it. Right, so also the stream server also maintains a stream state, basically having a picture of what's inside the terminal, like having a virtual view of the window, what state is the terminal in, where's the cursor, what is the current selected background and foreground color, etc. So the AVT library is also integrated here, as mentioned. Yes, so right. So the server also sends updates using Phoenix PubSub, as mentioned, to the consumers, and using just a update struct with some extra information. When the producer socket calls the stream server with a feed message, the data is being fed into this AVT, into this virtual terminal emulator in the state. We keep the reference to it in the state, but it's a reference to a Rust data structure thanks to the Rustler library. And it forwards the same thing to publishes, which gets forwarded. So basically everyone who is currently online will just rely on this being published and being sent in real time. But the purpose of maintaining that state is that if someone connects later, and I'm currently away for a moment, nothing happens. So we need to send the current state of the terminal to the viewer, because in the JS player also the virtual terminal emulator runs. So in all parts of the stack, it's there. Right, publishing topic, yeah, Phoenix track. Okay, viewer tracking. So I wanted to implement how many, like this little thing that says like 5 people watching or 5,000 people watching next to the stream. So I first look at Phoenix presence, which is kind of more popular sibling of this guy. But Phoenix Tracker is actually simpler and more suitable for this. So I use this module. Implementation is rather straightforward. Also use here updates track, which is being published when the viewer count changes. So different parts of the stack, different processes can subscribe to that. It exposes track and untrack functions, which the consumer sockets call. So whenever, we'll see that in a moment actually. You can always get a current count of the viewers from it, and you can subscribe for updates to the view count changes. Yeah, and here's a actual callback implementation of Phoenix Tracker. The Phoenix Tracker requires this one, and inside of it I just reshuffle it and publish it through PubSub. And one more responsibility of the stream server is keeping database schema up to date, like periodically taking a snapshot of a stream, saving it in a database, and then those snapshots get displayed as like small cards in a view on your profile, for example, when you stream. So the stream server uses the subscribe function, right? So it gets let's see, yeah. So it gets those messages, viewer tracker update messages, and stores it in its own state and updates the database on its own schedule. So it's not like overwhelming the DB if those things happen quickly. And Livestream Consumer. So this is the module that handles the process connected to the WebSocket of the consumer, the viewers. It also implements the Cowboy WebSocket behavior, just as the producer socket. This one uses Livestream Server for subscribing for stream events, so it can forward them to the browser. Uses also viewer tracker to subscribe, to register them, to register itself as a viewer, basically. So every consumer socket is counted as a viewer, basically here. So after getting a stream from the database, we subscribe to the feed, to different status messages, and we tell viewer tracker to track us. So the process, the consumer socket process, and we send them the initial header message of the stream. Yeah, and so after subscribing, we get those events. We can then forward the reply here. Tells a Cowboy WebSocket to send this message over the WebSocket to the front end. Yes, and this is important as well. So whenever a viewer WebSocket disconnects, we get this terminate callback called, and then we untrack ourselves from as a viewer, so we are not counted anymore. Right. Yeah, and here's one nice thing about Elixir and Airline, that those messages that are sent to the front end are binary messages, and the header message is quite simple. We have a feed message, so that's like basically that what got it includes what was printed to a terminal, and it's forwarded there. So the structure of a message here is like built from those little elements. I like to call this like reverse pattern matching, which is because it looks like a bit like pattern matching of binaries, but you're kind of constructing instead of deconstructing. And this is super easy, like in Elixir. Okay, live views. So other than handling the viewer, so the consumer socket basically talks WebSocket, and it sends the stream to the JS player, which doesn't use live view or anything. It just connects to the WebSocket endpoint and gets those messages and does it on its own. But there are a few live views that I use here. So here's my profile page. Again, the first card here is a preview card of my live stream. It's pretty much the same as the ones below, which are for the recordings that I uploaded earlier. But this one is live. It's semi-live. It's updated once every 10 seconds, but it updates, and it was kind of super easy to do with live view. I already had this card functional component, which is a stateless component, just renders a thing given its attributes, and I wrapped it in a live view just by putting it inside the render and subscribing to the stream metadata changes. So whenever metadata, such as a snapshot, preview of of the terminal window changes, this live view gets an update, assigns the updated, the new data to the socket, and then live view re-renders that. So this was just super easy to do here. Also, another live view, this small status bar displays like how long the stream is running for, how many viewers. So this was also super easy to do with live view here. Again, subscribing to some events from the stream server, and also subscribing for viewer count changes thanks to viewer tracker subscribe here. So that also was just a matter of implementing those callbacks, assigning few pieces of data to the socket, and it was live. Yeah, I guess that's it. That's all I have. Thank you very much. If you have any questions, I'm here.
Thank you very much. Are there any questions here? Okay.
Hi. You said that to communicate the current state of the terminal, you used some system based on events, and I just wondered if there was already some sort of protocol that was suitable for live streaming the terminal without streaming video itself, or did you have to come up with some protocol of your own?
So actually, there isn't. So the question is like whether I can get like a textual version of the terminal thing and not the.
It's just how did you come up with, or did you need to come up with some original implementation of transmitting those events and this current state of the terminal, or was there already some solutions of this kind?
No, so as for the events, there's not that many actually. Thanks to a pseudo terminal which basically allows me to intercept everything that the application running in a terminal outputs. So if a shell, I'm in a bash and I'm typing ls, then first goes the letter L, then goes the letter S. This is what the shell outputs to the terminal, and this is what I get by using pseudo terminal, by using the PTY. So I actually get the actual text that terminal emulator also gets it in the same way. I just get it first. But then I capture it, and then as for like synchronizing state of the virtual terminal, a representation of it across the stack, you really need to have a real terminal emulator, because every terminal emulator is a pretty complex state machine. It may seem like it just prints stuff, but it's just more than that. So you need to have a proper interpretation of all the text, and especially the control sequences that are invisible, but programs output those. So the AVT library that I use across the stack basically does the like interpretation, and by feeding all the text into it in those different pieces, in those different components, it builds up a state very similar to what your terminal emulator has, and it provides a method to querying the current state in a form of text that when fed into a new instance of such a virtual terminal, will get it into the same state. So basically, I didn't find anything like that. And of course, there's Xterm.js, a terminal emulator that you can run in a browser, but you can't really use that easily with Elixir or inside the Rust program. And all those solutions very often or almost always include some view, like GUI element to it. I needed something that's kind of like abstract and virtual, and that I can use. I can implement the rendering, like the view part of it, on the front end side, but I don't need any view part at the server or in the CLI. Although I really need to keep track of the internal state of the terminal workings. I'm not sure if I answered your question.
Yeah, thanks. Great talk.
Thank you.
Firstly, my question was to do with you mentioned using distributed Elixir, right? Distributed Erlang and
Yes.
the sorts. So you were using libraries like libcluster, Hot, and etc.
Yes.
My question is actually, were you running the different nodes on the same machine, or maybe on some different like physical machines within the same data center, or did you consider like scaling out this solution, or was it simply always on one computer?
No, it runs on multiple VMs in a UK data center. I don't know, those are two VMs. They may be on the same hardware, but they are separate nodes. Yeah.
Okay, thank you.
All right, any other questions? Okay, I don't see any. I've got one.
Okay.
So what was the reason for switching to Elixir from Ruby?
Okay. I planned more interactive features for the server side, and Elixir just felt like a better choice. And at the time, I was also transitioning from doing Ruby on Rails, and it just made more sense to me. So I think it was an excellent choice, like especially now when all those things can be implemented in a straightforward and robust way with Elixir. I wouldn't be able to do that with Ruby, like no way. So back then the streaming part was mostly in some future vision stage, but I had that in mind, so I thought that will be a good investment. Yeah.
It seems it paid off.
Oh,
yeah,
totally. And it's so much fun. So,
thank you very much.
Thank you.
All right. Any other questions someone came up? No, so let's give another round of applause for Marcin. Thank you very much.
Thank you.
Okay, and we can prepare for the third talk, which is going to be once again a remote talk. You can all see Zach, the creator of the Ash framework. Yeah, so without any further ado, Zach, you can start. Thank you.
Hey everyone, just raise your hand if you can hear me. Just make sure that I'm not talking into the void. Okay.
Yeah,
great,
it's
perfect. Fine. Cool. A lot of great talks ahead of this. You know, the instructor one made me immediately. I've been in my text editor writing an instructor Ash extension for the last hour because I was like, okay, we should have something like that too. So yeah, let me go ahead and pull up my presentation here. Ultimately, what I've landed on is I'm actually just going to sort of give a very similar presentation to what I gave at ElixirConf EU. And the primary reason for that is that we kind of, we've refined that a lot, and it was a lot of folks were pleased with it and kind of said, hey, you know, you finally managed to explain what you're trying to explain, which is a good thing to hear. So I'm going to go ahead and dive right in. So Ash Framework is a resource-oriented declarative design application framework. And the application framework bit is important, where if you've worked with Phoenix and you've worked with Phoenix contexts, generally speaking, they don't have any opinions on how you build your application. It's done via, you know, define your own modules and functions, which is I think it's a great opinion for a web framework to have. But in contrast to that, Ash Framework is an application design framework. So that's kind of, you can use these things together, and almost everybody who's using Ash is also using Phoenix. So it's not a competition, or we're not in competition. I think quite the opposite, is very complementary technologies. So the community is growing, which I think has been a lot because of the decisions we made recently, moving to Elixir Forum to have people go, you know, do support through the Elixir Forum. You know, you can see we've got a lot of posts coming through, and we've got our own fancy section now because Aston we had enough traffic that warranted getting this little custom forum section. So that's been nice. We also have a prog book coming. Rebecca Lee is doing a lot of amazing work. Most of the work, I want to make that clear. You know, I've been doing a lot of advisory and sort of writing with some of the super technical finicky bits. But Rebecca's really killing it. Her writing style is amazing, and I'm really quite excited for you guys to see what that looks like. So that should be out sometime soonish. Like, you know, these things take a long time, but we are actually well underway. So that's nice. So I'm going to start with a story of a function. And this is just to show kind of how our applications tend to grow over time. So this is a baby function. It's beautiful. It's simple, right? Everybody knows what this does. This returns to us all of our tweets. And it's very easy to understand. So this is a toddler function. It's honestly, it's still simple, right? If you look at this, you're not going to be like, oh my gosh, that's so complicated. I don't know what to do. However, I would say that this is headed towards a troubled childhood. So again, these problems are beginning to sort of seep in, and you'll see what I mean here, which is this is an adolescent function. Again, it's unpleasant. It's a handful. It's not the worst thing I've ever seen, right? But you can see this has a lot of opinions. It talks back to its parents, right? So it has these ideas of how you're meant to use it. You know, this stats option is kind of like a weird flag that will bring in some additional fields. And ultimately, this is kind of like the middle adolescent phase of a lot of our functions that we construct our business logic with. Okay, so this is a grown-up function. It's cleaned itself up. I would suggest that although it's nice, you know, its potential has been wasted. And there are millions of functions like this out there. I see them all the time. Our applications consist of these kinds of functions, right? Especially if you're building like your classic SaaS product, right? You just have these sorts of things all over the place. And this actually isn't bad, right? So I'm a consultant in my day job. And if I see this, I'm not like, oh gosh, no, throw it all out, you know, let's start over or anything like that. However, I think that we can do better. And that's a lot of the work behind Ash Framework. So let's clarify some terms here, because I use the word declarative a lot in the description of Ash Framework. And I'm just going to use imperative as a sort of contrasting term to declarative. So imperative is, you know, most things that aren't declarative is a better way to think of it. But in these design patterns, an imperative, you might focus on code, whereas on declarative patterns, you focus on data. You might focus on individual instructions with imperative patterns, whereas with the declarative design, you might focus on the end result. So an example here is, you know, telling your child, pick up your toys, put your laundry in the hamper, make the bed, or telling them that your room better be clean when I get home or there will be hell to pay, right? So you're not telling them exactly what to do. You're telling them that the room needs to be clean. And an interesting part about this is like this piece of advice isn't like you should use declarative design, doesn't mean a lot on its own. It only works when you have a smart tool, right? So this example we're not telling your child to pick up your toys, not telling them to put their laundry in the hamper. It only works if they already know how to clean their room. Like you have to have already told them before, they have to understand this concept. But you can't just say that the first time, right? Like you can't say clean your room if they don't understand what constitutes a clean room. So declarative design requires smart tools. And I think a good example of that is SQL, actually, right? So the SQL planner, the SQL optimizer, all that sort of stuff, really smart tool. And that's what allows us to have a declarative language that sits on top of querying data. So another important factor here is that imperative and declarative is relative. And this is maybe debatable. However, you've seen this over time historically that people call things declarative. It's relative to how much you have to tell the computer what you need versus how much you used to have to tell the computer what you need. So in 20 years, the stuff I'm talking about is going to feel imperative in a way because I have to give the computer so much detail compared to, I don't know, an LLM or something like that in the future. I don't really know. But so looking at this example, right, on the left, we're explaining how you go from the beginning to the end of a list. We're saying you start at 0, you increment a variable until it's the length of that list, and then you get that value out of the index like that. Whereas in this declarative example on the right, we just say for each item in the list, do this thing. We don't explain how to go from from the beginning to the end of the list. Using an example from Ash, we have policies on the right. Here's an example of doing it imperatively. This authorized access function, given an ecto query and a user, perhaps if they're deactivated, we want to say, no, you can't do that. If they're a super admin, we want to let them query whatever they want. And if they're a normal active user, we might say, okay, let's only show them published content. And if you look on the right, this is the same sort of thing. It's the same sort of workflow, which is, if they're deactivated, then it's forbidden. If they're a super admin, then they can see whatever they want. Otherwise, only show them things that are published. But there is I think an important difference here. So these policies are data. This is a sort of post-translation step a little bit here, right? But we actually turned this into a Boolean statement, and each one of these is a little behavior that tells us about that tells us how the properties of this check. And at some point, it turns into this, which is a little wacky, but we use what's called a Boolean satisfiability solver under the hood. And that satisfiability solver accepts statements in this format. But the thing is, like, this is, there's a little bit more metadata here that I'm obviously hiding for the sake of presentation, but this is actually what we pass into the solver. And you can't turn the code we were looking at in a couple slides ago into a solvable, you can't reliably turn it into a data structure that can be solved by a solver, right? It does one thing and one thing only, and it does it in exactly the order that you said, which, sometimes is nice, but other times it's a very limiting design pattern. So that leads us to this concept of artificial constraints. And I would say that imperative code imposes artificial constraints. And this exists all over the place. There's a lot of times where you realize, like, the way that I've written code, the way that I've written this has limited me. And once you see it, you can't unsee it. Once you understand that had you written it in a more declarative or more data-oriented way, that those same limitations would not be present, or that you would be free to pivot the implementation on top, without having to change the declaration. And once you start seeing that, it's you can't unsee it. So let's talk about some of these constraints that we deal with. Order matters. Here we go. So given this, these are 2 computed fields. These are functions that take a tweet and add some computed property to it, right? Let's just say that some computed field 2 has a dependency on some computed field, right? You can't just swap the order that they get calculated in. If you ever see some computed field 2, it must come after a call to some computed field, right? Which is, I would suggest, is a flaw that can be fixed in multiple ways, right? These are design problems that you can fix just with code. But ultimately, the way that we've implemented this means that we have to say it in the right order. And that's not a property of that doesn't have to be true for writing something that can compute data. A great example is an Excel spreadsheet, right? You don't have to tell the Excel spreadsheet what order to evaluate your cells in, right? It solves that problem for you. Okay, simple or optimized, pick one. This is a really classic thing that we see all the time. Just as, you know, doing regular day-to-day engineering, which is, you say this to yourself while you're writing code, this could be faster, but like, it's going to be way more complicated if I do that. And so we often make the correct choice to go for the simple implementation over like the theoretically fastest implementation or most performant implementation. But the fact that you often have to choose that can actually be factored away sometimes, right? There are ways, declarative patterns, to get both the simple and the optimized solution. So this particular issue is we join to the user table twice. We have this tweet query and we want to get it when it's for the active users, and we want to get it where it's from one of my friends. And we want those two, my presentation thinks I'm giving you a thumbs up. Anyway, so we want it to be able to, those functions to be used independently for active users and from friends of. But when you combine them, you make two joins to the users table. And the truth is that's not a big deal. Right? Like, it's simple. I'm sure your users table has an index on it for this particular case. It probably doesn't matter. And the solution is not worth it, right? So the solution is to make these sort of smart joiners. And we do this. I mean, I don't, but this is the sort of thing that you would do to optimize these issues, which is you would use named bindings for each join. And then you would say, well, hey, have I already done a join to friend link? And it's like, okay, I haven't. So now I can join to it. Same thing. Have I, joined something called user? And this technically works. You've got an optimized version of the same thing that doesn't join to users twice. Is it worth it? Probably not. And you also, what emerges from this is a different kind of problem, which is what I call accidental languages. So we've built in a bunch of semantics to this thing, what effectively amounts to like an optimization language, where we have this thing called friend link, and we expect friend link to be a certain thing. Like you can't join something else and call it friend link and not have a problem, right? Like it's a sort of locked in place concept what a friend link is. And that's the same with this user name that we have throughout here. These are terms in an accidental language. And I'm not against, in fact, I'm very pro the idea of designing a language for solving a problem. As you'll see, right? If you're familiar with Bash at all, I'm a big proponent of that sort of thing. But it should not be done on accident. It should be an intentional process. So let's change gears a little bit and talk about extensibility. Let's say we have this sort of classic example of like a Phoenix context here, where we've got these operations defined as functions, and somebody comes to us from the business side and they say, hey, we need to send data about user events to our analytics platform, or to some monitoring solution or whatever. Your options, like how do you extend all of these operations to do this thing? With this design, you have to put code in all three of these places, right? You could theoretically do it by modifying your repo, but that's a bad idea for its own reasons, right? You would put code here, and maybe that code is generic, like it's code that says like send analytics event, and then you look at what happened to figure out what the name of the event is or something like that. But you still ultimately have to go and modify all of these pieces of code. So they're fences in a way, what you'd call like an optimization fence, or in this case, an extensibility fence. Another thing that happens is we get these single-use functions, even though there are multiple ways to express the same concept, right? So in this case, we have you have a full name calculation. Again, these are just simple examples because these aren't how names work in real life. But here we compute the full name in Elixir with this full name function, but then we need to be able to, maybe we have a search bar that filters by full name, right? So we have to put that into our SQL query if we want them to be able to search by full name. This fragment here is the same thing as this, conceptually speaking. It's just a different implementation of the concept. And, you can do things like, you can add make a macro called full name just to illustrate that they're the same, but you still face the risks of implementation drift. And you still, the more you sort of, if you want to add, okay, well, how do I express the full name in this other context or in this other data layer? You're sort of back to square one. So this isn't really a solution to the problem, even though it does make it better. So yeah, functions can be used for one thing and one thing only. We also have a problem of limited composability. You can compose functions, right? But in very strict ways. So let's take these for active users functions and this from friends of function and say, well, I want to be able to give, say, or either they're from an active user or they're from one of my friends. So maybe we would make this function here, this or for friends of. And we're saying, okay, now we can pipe into or for friends of, where it has this or where instead of just a regular where. And there's a problem here, right? There is a bug in this. There's a pretty subtle bug, which is that this technically needs to be a left join. Otherwise, you think it's not just or where, it's also where they have any friend at all, because you're inner joining on the friends table, even if you aren't attaching a filter, right? So it becomes quite difficult, actually, and difficult in subtle ways to compose these sorts of things, because they actually have to be aware of how they're being composed. Like, you can't just pipe that into or where, or say like or these two things together. Their implementation must be fundamentally different on the inside in order to compose in certain ways. So these are the kinds of things that we aim to solve with Ash Framework. We're going to go back through the problems that we discussed, and I'm going to show you some examples. So we have our order matters here for sort of computed properties. In Ash, we can infer the order that these things must go through. And you're going to see some examples of calculations in a minute, but here you can see, like, we just say load some computed field and load some computed field too. And we've expressed in the calculation definition that some computed field 2 depends on some computed field 1. So you don't have to know that. It just happens. Simple or optimized. So you saw what we had to do to optimize this, but in Ash Framework, we would do this differently. So we would define calculations that map to these concepts of, for active user and from a friend. And we use these expressions here, which you'll see a couple examples of, but expressions are a data agnostic, a data layer agnostic expression. And so we don't actually provide like a procedural instruction to join. We don't say join to users, right? We provide a truth statement that the user for this thing is active, or that there is a friend link where the friend ID is this user's ID, that sort of thing. And then we compose those like this. We say where for active user and from friend of, and under the hood, the logic for doing this filter ensures that you've joined the minimal amount of times. It will use an inner join when it can, or a left join when it has to, right? And you'll see more about that in a bit, but this is an example of how I don't think that this is any less complicated. I think it's, or any more complicated, I mean, than this example. In fact, I think it's, a lot less complicated, because you don't have to see all of these instructions about how to join. And instead you just have the definition of, these as truth statements. And then you can use them in your filters. So we didn't have to trade simple and fast or optimized. And yeah, only joins the users once. So now let's talk about the accidental languages. We're going to go right back to the code we just looked, because we actually design these languages, right? We make these tokens, this for active user and this from friend, which again map to some statement, and we use them intentionally, right? We don't let these things sort of accidentally emerge. They become part of the language of our resource. This is, again, part of a resource. We're not going to dive too deep into exactly how resources work. There's getting started guides and all sorts of stuff that if you really want to, you can go through those. But this is where we favor actually design the language of your application. So close to extensibility. Adding cross-cutting concerns is kind of not possible with functions. You have to do it yourself. You have to put code in every single one of your operations. But with Ash, because these are what we call actions. These are one of the core things in Ash. They aren't just functions. They are data, which means that we can modify them. We can pop them open and add something to each action, and that's what this does. We had this thing called changes. Think of it like a plug, but for a change set. This global changes block actually happens for all of these actions. And you can also take that change and put it inside a single action if you wanted, for example, to only track an analytics event on specific actions, or if you felt that this was too unclear, that like putting this in a separate area could lead to confusion. But what's nice about that is you don't have to design it with that in mind. Like you make this change called track analytics event, and then you can decide where you want to put it and how you want to put it, but you get to opt into this amount of extensibility without having to change the operations if you don't want to. So we can talk about these single-use functions, and this is going to go back to the calculations example. But in Ash, we have a calculation using our data layer agnostic expressions. And so what that means is you might say, you know, filter by full name, and this will be translated to Postgres or to SQL. But you can also calculate in memory. Given like a first name and a last name, you can say, give me the full name. And this is just one small example of how you might do that. This exists sort of all over, but sorry, not next slide. So Ash will do this for you. You have to do certain, you know, give it some certain options. It's like, am I allowed to reuse values in memory? Because sometimes you'd like, no, I want you to fetch the stuff from the database. But Ash will actually use this property of expressions intelligently. So limited composability, this also goes back to calculations, but in this case, we noticed that it was difficult to, you can't really compose these things with an OR without giving fully different implementations. But given these calculations, they are composable by design because you aren't giving me imperative joins, you're giving me truth statements. What this means is I can AND them together, just like the original example. I can OR them together. And what's actually quite interesting is like this one will do an inner join, this one will do a left join. Actually, no, this one will do an inner join too because they both have to join to users. But this will do a left join on the friend links because it knows that this one doesn't join to friend links to be true, and therefore an inner join would not be the same logical statement. But we can also do things like this. This is a valid expression, which is we can say, if it's for the active user, then it should be from one of their friends. If it's not for the active user, then it should not be from one of their friends. I mean, this is a weird filter to write, but you can write it. And this will turn into a case statement in the database, which I thought I had an example of, but I don't. But this is a way that you can compose these even in ways you wouldn't have thought of it before, right? You're not just anding and oring them, right? You're using these computations anywhere in an expression. So you can use these in policies. So you can see we have this, if they're an active user, then you can only see this tweet if you're one of their friends. You can use these in atomic update statements. So these are statements like update increment, you know, like score +1 is an atomic update, right? Here's an example where we say, okay, set the status to published if it's for an active user or to pending if it's not. And this will be translated into the update statement that we make to the database. So this dovetails into atomics and bulk actions. So in the past, I've tried to go wide. I want to show everybody, look at all the cool things that we can do with Ash. But what I've found actually is that this is a better strategy is sometimes to say, look at the natural conclusion of these design patterns when we push all the way through. And atomics and bulk actions are a great place to talk about that. So here's an update action with a change in it that sets the attribute published to true. You can use this by saying ash.changeset.forUpdate, right? And then you can call update. This is a very sort of, you've seen this sort of pattern with Ecto where you might say cast, you know, the inputs, and then, you know, it's a little bit more action oriented in Ash, but it's a very similar concept. And then we have this question of what if I want to publish many posts? And I'm sure you've all been through the process of like, okay, well, I can't just insert a change set anymore, or I can't just update with this change set. I need to use like an update all, and then I need to rewrite the things that I'm updating to be like an expression, like using the Ecto query syntax. And our goal with Ash is to give you this data. You define your action, and for us to be able to do that transformation for you. So what that means is that we have to be able to turn this bit into an expression, this set attribute published true. To understand how we do that, you have to know what this is. Surprise, it's data, right? So that's not like a function that is doing things. It's just data. It's a convenient name for data, but this returns a module with some options, very similar to a plug. So in this module, it can tell us, here's how to do this operation against a change set in memory. This is very useful, even though, you know, the atomic is like the, maybe you might say more correct one or the more concurrency safe one. This is really useful for things like forms or for in-memory validation, all that sort of stuff. But we can also enhance these to support being done atomically. And so in this case, the atomic is very simple. It just sets the given attribute to the given value. But this would be a concurrency safe operation. So if we look at this and we say, make a query over post for the current user and publish, this will translate that into a single sort of the equivalent of an update all query. It'll say update all the posts, set the status equals published, where it meets this filter, which I would actually say isn't that impressive yet, right? Just this is not a significant win over other options. But this is where we get into extending this pattern to support all of the things that Ash supports. So let's take a look at a validation, right? We say the score has to, this is on a games resource where, you know, maybe whenever you do something, you get an additional point. And you say, actually, the score needs to be less than 100. And this will be translated into a SQL statement. Like, we can do this sort of, like, imagine you've got two people and they're incrementing the score concurrently with each other. And if the score ever goes to 100, that is an error. But you can't only rely on your in-memory data unless you want to lock. You can't rely on the fact that, like, maybe I say 98 and then I issue a SQL statement, you know, to add 1 and it becomes 101, and my in-memory validation doesn't work. So this is actually a significant problem for a lot of applications, especially Elixir applications, which are so concurrency focused. And you don't want to lock this game. You shouldn't really have to, is for these kinds of things. So we can actually lower that, all of your validations, all that sort of stuff, into the database for concurrency, safety, and performance. And another bit here is that we have policies. Ash has a sort of solution for authorization, and you can write your own authorizers, but the built-in policy authorizer is very powerful on its own. I don't know of anybody who's opted to write their own authorizer as opposed to use that. But as with everything in Ash, these authorization policies have to always be applied no matter what the context is around this operation, right? So sometimes you can write your policies in a way that we can't do them atomically, and we'll tell you, like, hey, you can't do this atomically. But there isn't a case where we just don't apply them because you're doing something atomic or anything. Like, you know, either it's going to be safe or atomic, and you'll know that everything's being applied, or it won't be atomic, and we'll tell you why. So what that means is we have to be able to turn these policies also into SQL queries or into expressions. And so if you look at that, we actually do this. So we can say, well, if the current score is 99 and the next score would be 100, you know, or let's say you're not allowed to, the policy in here is that you're not allowed to change the score from 99 to 100, right? So here we say, well, if you're changing the score from 99 and the next score is 100, then it's a forbidden error. However, if you're changing the score to 100 at all, then it's an invalid error. Now, these are actually sort of mutually incompatible statements because you can only increment the score by 1, but that's not important. But if you also look, we have this policy over reads right here that says you can only see one of these if you are one of the players in the game, and that's also applied in the exist statement here. So what that means is you have all of these concepts that you've leveraged, that you've been writing declaratively, like your policies and your validations and your changes and your updates, all that sort of stuff, right? And Ash can translate all of them into a single atomic statement, which allows you to have, again, concurrency, safety, and performance. And that means that this operation, these 5 lines of code, are extremely powerful. I guess 1 line of code, it depends on who you ask. But they're extremely, extremely powerful because this is now safe to do. Given a current user, I can say, increment the score of all of my games. And what this means is, for all the games that I can see, increment the score unless I've done something that is not valid, in which case show a validation error. And that's really powerful, because you don't need to all of a sudden, there's all these structures you don't need anymore. There's locking, there's, you know, statefulness to handle, like, okay, I've locked and I have this thing now, and now with this thing I'm going to increment, and like, no, just model the operation declaratively, and we'll figure out how to do all that for you. So to show a real life example of this, you know, because these atomics are relatively new and we're extending them throughout our ecosystem, there's a package called Ash State Machine. And what that does is it lets you turn a record or a resource into a state machine. So for example, this is like a package. Every time you send a package, you might store a package resource, you know, and it's like, it starts off as pending, and then the post office says, the post office says like, okay, we've received it, and then the customer will say it's arrived, and so the state machine models those transitions. But how do we make this transition state atomic, right? It's not just set the state to something, right? It's make a valid state transition. This is very important. You can't just say set it to pending unless its state was, or well, I guess in this transition state should say confirmed. But you can't set it to confirmed unless it's in the appropriate state already. And if you're using, you have to be using the appropriate operation to do so. So we actually do that. The transition state is a provided change by the Ash state machine. And I've omitted some stuff. It's not really important, but we can translate this requirement of what is a valid state transition and what states are allowed to go to and from into an expression directly, and we can return a validation error as a result of that. And what this means is all of a sudden you can now say, you can have like a confirm all packages button on the user's, you have your live view or something, and they've got 5 packages, and you can say like approve, they've all arrived, and you can use this to set them all to arrived. And you could filter theoretically if you wanted, you could say filter where they're in the state of on their way or whatever. But ultimately that's safe to do. It's going to follow the authorization rules, and it's going to be done in a single query. And in the words of one of our users, thinking about this, it makes me realize it's quite amazing. I would never have taken the time to make such an action atomic with just Ecto. I maybe would have locked if it were very important, but now it's just a drop-in, don't think about it feature. And this is an example of the sort of thing that you get with Ash all over the place, which is we give you a declarative tool, and then we actually implement things that are hard to implement in the specific. But because we've implemented them in the generic, it's actually quite easy for me to say, oh, well, how do I do that atomically? Here's the expression. And now you have bulk, safe for bulk operation, safe for authorization, concurrency safe, atomic actions that can be taken across, even things like your state machines, which have complex validation rules and may have their own policies and all that sort of stuff. So that's the end. I think that's a good example of where we're going, but there's tons of other features in the Ash ecosystem. So, if I've piqued your interest, take a look. We've got a lot going on, a lot of neat stuff. So let's see if there's any questions.
Thank you very much. Are there any questions here? Anyone? Oh, there's one in the back.
Thanks for the talk. I don't do really web development, so it may be quite a theoretical bullshit here, so sorry for that. But anyways, it seems like very macro heavy. Is there any particular reason for making quite a lot of macros there? Because problems with that I see potential is that LSP may be quite confused about that. And I'm personally a little bit confused about that too, because it's quite a whole new syntax I need to learn, and I'm curious about the reason why did you went for that way of creating the API.
Yeah, it's a great question. So it's macro heavy in the definition side of things. Like when you're defining your resources, there's very few macros otherwise. They're very the macros map closely to the structure that we're building under the hood. So very similar to when you might write an ecto schema, except we just have a lot more. There are a couple of reasons that we've done this, and we've explored alternatives. Before that was like this, we had things like def resource, or not def, but def resource, and then you had a list of attributes and all that sort of stuff. And ultimately, it's not data, when it's data at compile time. Let's think about it this way. It's more like we have the ability to enrich the syntax to support a lot more things because it's a set of instructions. Those are the macros, right? At compile time that we actually leverage to do more things than you could do otherwise. A good example is if an option accepts an anonymous function, we can actually support that. And it's quite a difficult thing to support if you're not writing a macro. So let's say you have change, you can drop in an anonymous function instead of a module. This is great for prototyping, that sort of thing. But that's not realistically possible if what we do instead is, say, have like an attributes function that returns a list of structs. And so ultimately, we can write things that are a lot more expressive that way. And to address the language server thing, it's actually quite interesting. Spark is the underlying tool that builds all those DSLs. That actually ships with an Elixir Sense extension that plugs into Elixir LS, for example, and provides better autocomplete than what any language server could give you for those macros. So like we give you type-aware, context-aware autocomplete. Like if you are going to say like put in a value into a list that expects a module that implements a behavior, we only show you the modules that implement that behavior. Or if there's like a list of valid atoms, we'll allow you to complete only the atoms that are there. Or if the default, it's a Boolean flag and the default's false, we know that you're only typing it to set the default to true. So if you hit tab when you autocomplete it, we set it to true, right? And the documentation is there in line on all that sort of stuff in a way that actually is better than you could do even if it was data. So we would have written that. We would have written that even if it was a bunch of structs that you were writing anyway, because it's a massive developer experience improvement. So ultimately, to sum it up, the reason is that macros allow us to give you a richer language for defining these things, and I don't think that they are the same. I don't think they have the same problems as macro-heavy things when they're like transformative at runtime, or like producing a bunch of complex code. Like mostly, those macros just create a data structure. You can inspect the data structure when you're done as well. You can just call a single function spark DSL config. It gives you a big map. You can see all the data. So you don't really lose a lot, but you do gain a lot more, in my opinion.
Thanks. It's really interesting, especially about the LSP part. And another question, like Ash seems like a really high-level tool. Did you ever like encounter the problem that the tool being high-level is limiting, like it's not enabling some possibilities that like writing a low-level tool, like writing low-level code would enable? And are there any escape hatches that you can use to like fall back to like a low-level approach?
Yeah, it's a great question. It's a really common question, because it is, your spidey sense should be tingling when you see stuff like Ash. You should be thinking, hold up, what if I need to do something you didn't think about? And ultimately, I would say like that was my frame of mind when building it as well. I've worked with restrictive abstractions before and was like, we need to do better, because I think we need to have both. I want my high level abstraction, but I don't want to throw away the flexibility that I get from other design patterns. So we have tons of escape hatches. And what's nice in my mind, right? Although it is, you have a lot of escape hatches you might need to look at or learn, but they're progressively complex, right? So for instance, you have regular escape hatches, like dropping in a change that says, go do some custom stuff and give me some attributes that are supposed to change and stuff like that. But we also have the ability there's a thing called modify query, where you get the ecto query for the corresponding action and you just do whatever you want with it, and then you give it back to us. We have generic actions, or we have manual actions, where the action semantics are the same, but you get to take over the bit that would dispatch to the data layer. So like, let's say you actually want to do some stuff and then you want to call the data layer. We have generic actions, which are unstructured actions. It's just, you get our typed arguments, which are nice, and your typed output, which is nice. But then it's just some function that you call that does whatever you want. And so you get all these progressive escape hatches, up to and including just not using Ash for a thing. Like Ash doesn't take over the whole structure of your entire application. It's just a piece. So if you want to write a Phoenix controller that does whatever you want, there's nothing stopping you. And yeah, so I think in our experience, like I have not yet had a point where somebody came, and people have been in production with this for 3-4 years now, and nobody's like, I literally cannot figure out a way to do this because Ash backed me into a corner. Like it's really just a matter of to what degree you might need to use an escape hatch to accomplish what you want to accomplish. And even then, it's like, it's a lot more flexible than it looks. So yeah.
Great, thanks.
Mm-hmm.
All right, any other questions? Okay, I don't see any, so thank you very much for your presentation, Zach.
Thank you.
All right, and now time for our last but not least presentation. Łukasz is going to show you a thing or two about the Elixir WebRTC implementation.
Hi, can you hear me? Hello, hello. Oh, so my talk is quite short and not very code heavy, so hopefully I won't bore you to death. All right, so today I wanted to tell you a bit about the project that me and Michał, the guy over there, have been working on for almost a year now. And this is the WebRTC implementation, the Elixir programming language. So we are very close to the second release, 0.2. And I thought this is the perfect occasion to tell you a bit more about the WebRTC itself, why we decided to implement WebRTC in Elixir, and how you can use the library right now. So before I start, I'm Łukasz. I work here at Software Mansion as a software engineer, mostly, not surprisingly, on multimedia stuff in Elixir. And you can find me on GitHub and on Twitter under these handles. All right, so what is WebRTC? It is a communication standard that was developed in the last decade. The development effort was led mostly by Google, which allows you to transmit audio and video between some kind of peers over the network, as simple as it gets. But the main selling point of WebRTC is the very low latency, hence the RTC, real-time communication in the name. And because of that, WebRTC is the default technology to use in some kind of video conferencing scenarios when the latency is important. Another important thing is the support in browsers. So all of the major browsers implement WebRTC, so you can use it in your web apps thanks to high-level JavaScript APIs. And this is also the reason why, for instance, when joining a Microsoft Teams meeting, you can do that directly from a browser instead of downloading a native app. WebRTC was designed to be peer-to-peer, which means that when creating something like a maybe one-on-one meeting app, you can transfer the media data directly between the peers instead of using some kind of relay or forwarding server. So you save on the infrastructure and make the latency even lower. And lastly, this is an open source standard. And also the reference implementation, the libbWebRTC, is also open source, so you can read it freely. So like I said, the typical scenario for WebRTC would be something like a video conferencing solution, where you connect some amount of peers, maybe using the peer-to-peer approach, like in this case, or maybe using some kind of relay server in the middle. And basically, all of the big players in the video conferencing scene use WebRTC. Google Meet uses WebRTC, Microsoft Teams uses WebRTC, Skype, Discord, Zoom, probably WebEx, and probably many more. To get to know how WebRTC works, we would have to take a look at the specification. This is one of the RFCs, the media transport and use of RTP in WebRTC. But I guess before diving into that, we also should take a look at the JavaScript session establishment protocol. But I guess it's worth mentioning also this one. And this is also quite important, and this is quite crucial as well. And without this, you couldn't implement WebRTC at all. And there's this one, and this one, and also this one, and also this one, and probably many more. And the conclusion here is that WebRTC is quite complex. It is not a single protocol, like HTTP, let's say, but more of a mixture and combination of different kind of standards and protocols that are battle-tested, mature, and are all combined and hidden underneath high-level JavaScript APIs. So this diagram shows you more or less the layers in WebRTC when it comes to the technology stack. We start at the bottom with the network stuff. So WebRTC usually uses UDP for the sake of the low latencies. Because in TCP you have to do the handshake, you have all of the reliability features, which makes the latency quite a bit higher. Thus, we use UDP in WebRTC when we can. Then there's ICE, STAN, and TURN, which are the protocols used to establish the peer-to-peer connection. Because we use IPv4 and NATS, network address translation, establishing a peer-to-peer connection is not as straightforward as it may seem. So the protocol ICE allows you to do so even when both of the peers are behind some kind of NATs, even multiple layers of NATs. And in some rare cases, when peer-to-peer is not possible at all, we can use a turn server to relay the traffic from one peer to another peer. Then there's the DTLS, which is basically a TLS for UDP, and the S in SRTP, which stands for secure. These allow you to enable the encryption WebRTC, and encryption WebRTC is enabled by default, and this is actually mandatory, so you don't really have to care about that aspect of security when using WebRTC. Then we have the protocol that actually carries the media itself, which is called RTP, Real-Time Transport Protocol. It adds some features like sequence numbers, because obviously UDP does not ensure ordering of the packets. So we need that. It adds timestamps, so you can properly play the media back on the receiver side, using proper FPS for video, let's say. And on the other hand, we have the protocol called SCTP, which we can use to relay non-media data over WebRTC, which is also possible, but we're not gonna dive into that today. And there's the high-level JavaScript APIs, pure connection for media, and data channel for non-media stuff. Let's take a look at how the API looks, pure connection in this case. This is a snippet in JavaScript. You can run it in the browser, and it allows us to establish a peer-to-peer connection with some kind of other peer, may it be a browser or maybe a native implementation. We have to start from creating the RTC peer connection object, and then we can add tracks to the peer connection. A track can be obtained from other APIs available in JavaScript, like the Media Devices API, which allows you to grab a track from a webcam, a microphone, maybe a screen share, and add the track to the peer connection. We can also set up the on-track handler, which will handle the tracks from the remote peers. In this case, we simply attach the track to an HTML video element. Then we have to create something that is called an offer. Offer is a text message that uses protocol called SDP, another one. And the SDP is an acronym for Session Description Protocol, and as the name implies, it describes the session, so the number of tracks, type of tracks, is it audio, is it video, codecs used. It carries stuff like IP addresses and ports for the peer-to-peer establishment, certificates for DTLS, and some more stuff. We have to create the answer, set it as our local description, and then we have to somehow send the answer to the other peer. So even though WebRTC itself is peer-to-peer, so the media is transferred peer-to-peer, we have to somehow get the offer from one peer to another, and this is not specified by the WebRTC itself. Usually we use something like a WebSocket server to relay the messages. So we get the offer to the other peer applies the offer, he creates an answer, and then we get the answer and we can set it as a remote description ourselves. And this is when the media transmission begins, and assuming that the other peer added some tracks, we can actually see the video or audio in the HTML video element. Right, so this is WebRTC. Now let's ask the question, why would you want WebRTC in Elixir? I'd say it would be quite nice to have WebRTC in Elixir. Firstly, let's assume I want to build something like an SFU, which is a selective forwarding unit. So basically a server that forwards traffic from one WebRTC peer to another. And if you think about that, the beam was originally designed to be used on a telecom switches, which is a very similar use case. So because of that, beam, and by extension Elixir, seem to be the natural choice for this kind of scenario, at least when thinking about higher level languages. Secondly, we have the membrane framework, which is a multimedia framework that we developed here at Software Mention. And it would be quite nice to have WebRTC in membrane, because WebRTC is basically the technology to use when you want to get media to or from a web browser. And we do have a working WebRTC implementation in membrane that is membrane-based, but it's got some issues. And I'm going to tell you about the issues in a second. And lastly, we just want to grow the ecosystem, get the Elixir people interested in WebRTC, get the WebRTC community interested in Elixir, and simply creating the WebRTC implementation would not only give the WebRTC implementation to the ecosystem, but also generate some kind of interest around multimedia and Elixir, which is a win-win both for the community and for us as the implementators. So now we are sure that we want to have Elixir WebRTC implementation, but why create the second one when we already had the membrane-based one? So firstly, we had some issues with the dependencies. We used some dependencies both in Erlang and C as NIFs, And maybe sometimes we wanted to contribute to the dependencies, but the dependencies were not properly maintained. Sometimes we had to create the forks of the dependencies and then maintain the forks. And because we did not implement the libraries, obviously, our understanding of the underlying protocols might not have been the best, which resulted in some issues along the way. Secondly, the API to the membrane WebRTC plugin was completely non-standard and not similar to the JavaScript API at all. So when you wanted to use it, you had to not only learn WebRTC, then you had to learn membrane, and then you had to learn the API of the membrane WebRTC plugin, which is a struggle. And after working with WebRTC for some time, we realized that WebRTC does not map really well to the pipeline model, and membrane is all about pipelines. So this came with a lot of unnecessary complexity, which in turn made the plugin harder to maintain. And also, it came with a performance penalty. So now we are really sure that we want to implement WebRTC and Elixir. What are the goals of the project? Firstly, we want to keep the Elixir API as close as the JavaScript API. So let's take this snippet in JavaScript. It maps directly to this snippet in Elixir. And if you take a close look, you can notice basically one major difference. The peer connection in JavaScript is an object, but in Elixir, it is a process. So except for this kind of differences that we made to keep the Elixir implementation idiomatic to Elixir, the APIs are basically identical. So if you're familiar with the WebRTC API, you feel right at home with the Elixir. Next, which is a kind of an extension of the previous point, we wanted to make the Elixir WebRTC as easy to integrate into Phoenix project as we could. And one step in that direction was to create a live Phoenix Live Dashboard extension for Phoenix, which you can add with basically 3 lines of code, and you get this kind of dashboard that shows you statistics about WebRTC for free. And we kind of mimicked something that is available in Chrome. So if you type Chrome WebRTC internals, you see this kind of statistics about WebRTC. And this is basically the same thing, but for the server side of things. And lastly, we learned quite a lot of stuff about WebRTC when implementing the standard. A lot of stuff we learned when playing with the APIs, and all of that stuff is not very easily searchable on the internet. So we wanted to gather all of the knowledge, or at least part of the knowledge that we gained in the mastering transfer guide in the XWebRTC docs. If you want to know what a transfer is, I guess you have to read the guide. It is in the library docs, so it uses Xdoc, and it's really pretty. And it shows you some examples of more advanced use cases of the API with both snippets in JavaScript and Elixir WebRTC. And it should be a nice reference when working with WebRTC in your application. All right, so now we are at the point where we have an implementation of WebRTC in Elixir that is very close to being feature-full. So what we can actually do with the implementation? We've created some apps, or some example apps that I'm going to show you. First one is Reco from Recognition. It is a simple Phoenix web app where the client sends his video from webcam to the Phoenix backend, obviously using WebRTC, where the video is fed into machine learning model using Elixir NX. The machine learning model does some kind of image recognition, spits out the name of the item on the image, and sends the item name back to the user. And this is how the interface looks. And I guess this is an example of an app that is not very multimedia streaming centric. So like the WebRTC is not the focal point of the application, but I would argue it makes the user experience quite a bit better because of the low latencies. And I've seen people use something like sending JPEGs over WebSocket for this exact kind of scenario, which is good. And on the other hand, we have the app called Broadcaster, which is a WIP web broadcasting server. WIP and web are protocols based on WebRTC, but as you may remember, in WebRTC you had to do the offer-answer exchange by yourself. On the other hand, WIP and web standardize the process of exchanging the offer and an answer using some kind of simple HTTP requests, which makes WebRTC a viable option for broadcasting and live streaming. So in this case, we have some kind of source. In this case, this is OBS, and some kind of clients. In this case, these are web browsers. And we simply stream the image from the OBS to the clients. And if you're watching this, if you are watching this meetup on the experimental WebRTC broadcast, this is exactly what we use there. So, and as you can see, the latency is very quick, something like less than half a second. And we tested that a minute ago, and the latency is about 20 seconds lower than on YouTube, which I don't want to brag, but maybe it scales a bit worse. But and these are the apps that we made, and that's basically the Elixir WebRTC. Now you know what WebRTC is. You know that there's WebRTC implementation Elixir, and I have some examples of apps where you can utilize WebRTC. Thank you very much for listening. And this is a QR code for the Elixir WebRTC repo on GitHub. And here are the example apps, the repo with example apps that I've just shown you. Thank you.
Thank you very much. All right, are there any questions for the last presenter? I guess everyone is really, really hungry right now. So thank you again, Łukasz.
Thank you.
And that's it for today's meetup, for our presentations. Thank you all for coming. Thanks for the listeners online. And now is the time to actually enjoy the pizza. As you can see, it's over there. You can also get to the kitchen and grab another beer or juice. Thank you for coming, and see you next time.
Chłopaki, to jest awesome.